On this 2019 to 2024 Ram 1500 Classic with the 5.7 Hemi P0072 is an ambient air temperature sensor circuit low fault. In plain language, the controller may be seeing the outside air temperature signal pulled lower than it expects. The truck may turn the MIL on, and the outside temperature input can be unreliable. The broad possible fault areas are the ambient temperature sensor and connector, the signal circuit, the sensor ground side, or in fewer cases the module input. Temperature sensors are typically variable resistors that work as normal two-wire 5.0-volt sensors, so we are going to prove the circuit response before replacing anything. If other codes are present, check what they mean first, but keep this episode focused on the circuit low fault. Before testing, understand what the controller is looking for. A voltage reading above approximately 4.9 volts would set a circuit high or open fault, and a voltage below approximately 0.10 volts will set a circuit low fault. For the circuit low setting point, the sensor signal voltage is below a calibrated threshold, typically in the 0.1 volt range. For the circuit high setting point, the signal voltage is above a calibrated threshold, typically in the 4.9 volt range. Circuit high and low faults are monitored with the ignition on and battery voltage above a calibrated threshold. Performance checking is a different gate. Ignition on after an 8-hour cold soak from the previous engine off cycle, with ambient air, intake air, and engine coolant temperature values above -64 degrees C, -83 degrees F. A performance fault is typically when the sensor signal is irrational, not within 10 degrees C, 15 degrees C, 18 degrees F, 27 degrees F, of the other engine temperature sensors. Also remember, circuit high and low faults are monitored by both the PCM and BCM, but only the PCM performs the rationality check of the AAT sensor signal. When you get to sensor confirmation, compare resistance against the temperature chart and allow for the listed variation. The actual resistance can vary +/10% from the values in the table. Useful reference points are -40 degrees C, -40 degrees F, 345, 26 k ohms as the lowest possible temperature reading, -10 degrees C, 14 degrees F, 53, 38 k ohms for logical temperature values, -5 degrees C, 23 degrees F, 40, 89 k ohms, 0 degrees C, 32 degrees F, 31, 56 k ohms, 5 degrees C, 41 degrees F, 24, 55 k ohms, 10 degrees C, 50 degrees F, 19, 24 k ohms, 15 degrees C, 59 degrees F, 15, 22 k ohms, 20 degrees C, 68 degrees F, 12, 13 k ohms, 25 degrees C, 77 degrees F, 9,720 ohms, 30 degrees C, 86 degrees F, 7,780 ohms, 35 degrees C, 95 degrees F, 6,370 ohms, 40 degrees C, 104 degrees F, 5,200 ohms, and 150 degrees C, 302 degrees F, 181 ohms as the highest possible temperature reading. Start with the basic system checks before getting deep into pin testing. Look for any service bulletins, online cases, or flash updates that apply to this code or symptom. Then check the ECU for any battery voltage codes, because low battery voltage can set a DTC and send you down the wrong path. Since this is a circuit fault, handle circuit faults before chasing rationality or performance concerns. Before unplugging anything, look at the ambient temperature sensor connector where the sensor is installed. Make sure it is fully seated and locked. Then disconnect it and inspect for water intrusion, pushed out terminals, damage, corrosion, burnt terminals, or spread terminals. The sensor location can vary by build, so identify the correct sensor and circuit for the vehicle in front of you. Next, read and record all codes and captured data. Save a vehicle scan report if needed. Then clear the codes and reproduce the captured operating conditions. If P0072 returns or the condition is present, keep going. If it does not return, treat it as intermittent and work it that way. For an intermittent P0072, use the captured data and monitor gates to operate the vehicle under similar conditions, and let the diagnostic run. Check that the related components and systems are operating correctly before trying to diagnose a fault that is not currently duplicated. Recheck for flash updates and bulletins before spending time on an intermittent. If nothing applies, wiggle test the harnesses that carry the circuit while watching for the code to go active or the scan data to change. Check the battery or batteries for proper charge and operation. Verify related chassis grounds, and inspect the component, module, and inline connectors for locked connectors and terminal damage. If you are using a scope, back probe the temp sensor signal circuit and monitor voltage during the wiggle test. If you cannot watch it live, set the trigger for voltage above 4.9 volts for an intermittent circuit high fault or below 0.1 volts for a circuit low fault. If you have the electrical test lead kit, use it to check the controller, signal circuit, and sensor ground circuit together. Connect kit, electrical test lead 2,064,100,081 to the temp signal and sensor ground circuits at the temp sensor harness connector. Switch the tool between open and closed while watching the scan tool. In the open position, the voltage should be 5.0 volts. In the closed position, the voltage should be 0.0 volts. Then move the switch to adjust and vary the resistance while monitoring ECU signal voltage on the scan tool. If the faults and voltage responses happen as expected, the ECU and wiring are reacting correctly, so inspect the sensor connector carefully before condemning the sensor. If the signal is stuck low or only the circuit low fault sets, focus on the temp sensor signal circuit shorted to chassis ground or shorted to the sensor ground circuit. If that signal circuit is not shorted, inspect the related connectors for terminal problems before condemning the ECU. If the signal is stuck high, or only the circuit high fault sets, the most likely cause is an open or very high resistance in the temp sensor signal or temp sensor ground circuit. With voltage still present when the tool is switched closed, move the test lead off the sensor ground circuit and onto a good chassis ground while watching the scan tool. If the voltage drops to 0.0 volts, the resistance is in the temp sensor ground circuit. If voltage is still present, the resistance is in the temp sensor signal circuit. Check the appropriate circuit for high resistance. Typically, it should be less than 3.0 ohms. If the circuits do not show excessive resistance, inspect all related harness connectors for pushed out, spread, corroded, or dirty terminals before condemning the ECU. If no issues are found, the ECU replacement decision is supported by this test path. If you are using a DVOM instead, first verify the temp sensor and ECU harness connectors are connected and locked. Turn the ignition on, back probe the temp sensor signal circuit at the sensor connector, and compare the meter reading with the scan data. If the signal voltage is reading between 0.1 and 4.9 volts, the temp sensor signal is most likely giving a legitimate reading. If the signal reading has a constant voltage above 6.0 volts, that indicates the signal circuit is shorted to another voltage supply. If the DVOM result points you toward the signal circuit check, disconnect the temp sensor and ECU harness connectors and check the temp sensor signal circuit for high resistance and short to ground. If the signal circuit checks good, inspect all connectors in the system for pushed out, spread, corroded, or dirty terminals before condemning an ECU. If the DVOM result points you toward the sensor ground side, move the test lead and back probe the temp sensor ground circuit at the temp sensor harness connector. For a typical active circuit low fault, quickly eliminate the temp sensor as the possible cause by disconnecting the temp sensor harness connector while watching for the circuit high fault to become active on the scan tool. If the circuit high fault becomes active when the sensor is disconnected, the temp sensor is most likely faulty. If it does not become active, keep going. Disconnect the ECU harness connector to isolate the circuit. Check the temp sensor signal circuit for continuity to chassis ground and to the sensor ground circuit. If there is continuity to either one, repair the signal circuit for a short to ground or a short to the sensor ground circuit as indicated by the test. If the signal circuit is not shorted, the ECU replacement decision is supported by this test path, but only after the connector and circuit checks are complete. Even though P0072 is the low circuit code, the high side response is useful when you are proving whether the circuit can move correctly. For typical circuit high diagnostics, disconnect the temp sensor harness connector and measure the temp sensor signal circuit voltage with the ignition on. The signal circuit voltage should be between 4, 9 and 5, 6 volts. If that voltage is correct, monitor the scan tool and connect a jumper across the terminals with the ignition on. Typically, the temp sensor signal voltage should change to 0 volts on the scan tool with the jumper in place. If voltage data is not available, check for the circuit low fault to set with the jumper in place. If either result occurs, the temp sensor is faulty. If the voltage does not change to 0 volts or the circuit low fault is not present with the jumper in place, check the resistance of the temp sensor signal circuit and temp sensor ground circuit. Typically, the circuit resistance should be less than 0 ohms. If the signal and ground circuits test good and the voltage is still reading high or only the circuit high fault is present, inspect all related harness connectors before condemning the ECU. If no issues are found, the ECU replacement decision is supported by this test path. For performance, rationality, or intermittent checks, disconnect the temp sensor harness connector and connect the electrical test kit leads to the temp sensor harness connector. Move the switch on the tool to open. The signal should read 0 volts and a circuit high DTC should be active or pending on the scan tool. Then flip the switch closed. The signal should read 0 volts and a circuit low fault should be active or pending on the scan tool. If there is voltage present between 0 and 0 volts with the test tool in the closed position, that indicates likely resistance in one of the circuits. To separate which side has the resistance, remove the test lead connected to the temp sensor ground circuit and connect it to a good chassis ground. If the signal changes to 0 volts, the temp sensor ground has resistance. If voltage is still present, the temp sensor signal has resistance. Confirm the suspect circuit issue by isolating that circuit and measuring resistance between the sensor and ECU harness connectors. If no resistance is measured, carefully check the connectors in that circuit path for spread or dirty and corroded terminals. If the circuits check good, verify whether the issue is with the temp sensor or ECU. Temp sensor performance faults often come from resistance in a circuit or a sensor that is stuck or drifted out of range. If a temp table is available, dial the tool to a resistance value in the table, connect both leads to the harness connector with the ignition on, and monitor the scan tool for the proper reading. If the scan tool reading matches the table, the temp sensor is likely faulty. If the actual temperature can be acquired or reasonably estimated, measure resistance across the sensor terminals and compare it to the table. If the sensor resistance is not in range, the temp sensor is likely faulty. If a temp table is not available, connect the electrical test kit leads to the harness connector, switch to adjust, turn the ignition on, and slowly vary resistance while watching scan data. The temperature or voltage value should change with the resistance change. If it does, the temp sensor is likely faulty. To verify an ECU failure, open and short the circuits while monitoring signal voltage and fault status. If the expected voltage readings or DTC responses do not occur when opening and jumping the connector, and the circuits are not shorted or open, that indicates a faulty ECU. Before condemning an ECU, carefully inspect every connector in the circuit path for water intrusion, spread terminals, pushed out terminals, burnt terminals, or corrosion. Keep verification separate from testing. After repairing AAT wiring, replacing the sensor, or disconnecting the BCM connector during testing to correct an active DTC, the vehicle must be driven for a minimum of 5 minutes above 15 mph to update the AAT temp signal before the DTC will go stored and can be erased. Then verify the repair and confirm the code stays gone. Takeaway. For P0072, prove whether the low signal is caused by the sensor, a grounded signal circuit, a sensor ground issue, or the module input before replacing anything. For more diagnostic training, visit stepdiagnostics.com.